Hello, everybody. Welcome and a warm welcome from the SGT to this year's first and hopefully last virtual conference. Today we have three papers from Hans Mahrenholtz, Glass Service, Ireson from Glass Futures, and Marcus Reinhardt from Saveway. Before we start, can I ask that you all turn off your camera and microphones? If you want to ask a question, please write your question in the Q&A icon, and I will ask the question on your behalf, or via a hand wave icon. And I'll ask the question at the end of the presentation. The conference is being recorded and will be available on the SGT website. Can I remind committee members to complete the Michael Garvey Award questionnaire? So we'll kick in straight away now, and I will introduce Hans is Mahrenholtz from Glass Service. Hans is a 58-year-old who holds a engineering degree, from the Technical University of Doghouse, Germany, in ceramics, glass, and energy process engineering. Hans started his business career with Sorg, Germany, being in 1989 and ending in 1994 as assistant to the R&D manager. From 1994 to 99, Hans ran his own business offering glass-specific software and project management for glass manufacturing companies. From 2000 to 2009, Hans worked for Linde Glass Division in Germany, ending as the head of industrial segment glass and fibers, responsible for R&D and new sales within the global glass industry. In 2010 to 2015, Hans worked as general manager for Glass Global Consulting, responsible for engineering and consulting business. Since the 1st of December 2015, Hans has worked as senior sales consultant for Glass Service in the Czech Republic, with the main activities of consulting, including surveys, audits, and due diligence, and also project management, software development, and marketing. And since 2021, Hans has been secretary of IFG's TC09. So I'll hand over to Hans.
Yeah, so good evening, everybody. Good evening, ladies and gentlemen. I would like to welcome you to my presentation. First of all, I would like to know if everybody can see my screen now. 1 second, starting my presentation. So can everybody see my presentation?
Not yet.
No.
No, okay, I have to share the screen now. Okay. No.
That's fine.
That's good. Okay. Okay, so I do not need to introduce myself. I think this was very nicely done by Nigel. I would like to say thank you also to the SGT to giving us the opportunity for such a presentation. Okay, the title is A Different Approach to Furnace Audits, and I would like to explain this now a little bit in detail. Okay, so you are wondering why there is a desert. It is Wadi Rum in Jordan. It is just showing that audit is a quite dry topic. I cannot show a nice video, or I cannot show a nice product, because an audit is a process or an activity where we are documenting, where we are checking documents, when we are giving proposals. So it's a quite dry topic. But I try to overcome this and make it interesting for you. So when a year ago, Stuart Hicks asked me if I'm interested to give a presentation about audits, and I said yes. And a few weeks ago, when SGT announces the presentations, I have seen that A Different Approach to Furnace Audits is the title of my presentation. So I wasn't asked, so I have to deal with this kind of wording. a different approach. I'm not sure if it's different. So, but I think we do it in a different way than others because we are based, it's really based on expertise, and we're doing it. This is an audit, but it's not always a furnace audit. It can be a feeder audit. We do sometimes projects when we are doing an audit for feeder. Furnaces, but this is the biggest part of the plant. So I can say approach to furnace audit, it's correct. Glass service, it is just one slide. What is glass service? Glass service is a group in the meantime, started 30 years ago in the Czech Republic. Glass service, then Flamatec. Flamatec is very known for burner equipment, burners, FIC, Stuartex for electrical components, so electrodes and everything what is around electricity. Airson, advanced sensors and cameras. So in principle, you see here, we have a very good mixture of things. More than what I explained you, glass service is very well known for simulations. We have done more than 800 simulations. We are also known for expert system. I would say it's our blockbuster with more than 300 installations. So right now, and we are overbooked for a long, long time. Because it is in Corona time, we have learned that people want to operate things autonomous. This is a trend, and we are very well prepared on that. Also the cameras, it's also very, very efficient and very, very successful right now, because this is also sometimes something what can be autonomous. Expert system is being said, but we have all the other things like burners from Flamatec. We can supply raw materials, so many, many things. Now coming to the content of the audit. So in principle, I would like to clarify first what is the difference between audit and inspection. Then I would like to define what is an audit in general. So why an audit? What is the motivation? What is the motivation for an audit? What are the phases of an audit? What tools do we typically use? I give you a few examples and some details. I would like to speak about what report you as a customer can expect. And of course, I will speak a little bit about our references. From the boundary condition, I think an audit is much more than an inspection. But I will come when it comes to the definition what is an audit. So, but we have many things. You can find inspection, analysis, assessment, due diligence, study, survey, report. There are many, many words of work, what consultant people are doing. But audit, from my point of view, is something more specified, and I will come to that now. An audit, if you are looking into the internet, you'll find many, many different definitions of audit, and there is not one. Because typically audits are more on financial side, from tax, from those things. So from my point of view, and I come to that now, I would like to define, or we define audit as a thorough, systematic, independent, and documented process with various activities such as examination, inspection, investigation, and so on, supported by an expert assessment to document, to localize the problem, to identify potential, to evaluate solutions, ideas, proposals, or review documents. So, for example, if you are just checking the furnace conditions by a camera, then this is not an audit, this is an inspection. An audit is if you now draw conclusions from that, or you analyze this with others, or you give some ideas to overcome that, then this could be an audit. For me, an audit is more just one activity. Okay, you can have a first part audit. This is typically internal. Second part audit, this is what most cases Glass Service is doing as a supplier or as an independent party who is checking something. The third party is, for example, I made once an audit for Coca-Cola. It's long, long ago, so I can speak about in the Middle East somewhere, and they wanted me or us to audit the glass production. So this is a third part audit. Sorry. When it comes to the types of audits, so we can have many different types: construction, environment, performance, process, and so on. And what we typically do is operational audits. That means we are looking into the operation and not into the financials, into the financing things. But of course, we can have many, many different types of audits. So sometimes what we also do is conformance audits, and I will explain this now. So that means we will check if some ISO norms are conform or not conform, and so on. So we can check many, many things. But the issue is that every audit is different. It's not one audit is like the other. So we have done many, many audits, but it's not one audit the same as the other. So when it comes to the principles, I think it is crystal clear that you have, as an auditor, you have to be integer, you have to be fair, you have to do this with care, you have to do this in confidence, no doubts, and you have to do it independent. Me as being glass service, I can be very independent. For example, if I find out in an evaluation that I suggest that the customer is doing a study of modeling, then I can say I suggest a modeling study. I do not say I offer a glass service simulation study. I would say a modeling study. And also an audit, there is no connection internally with some other departments, and there is no reduction when it comes to another project. So I think independence is important. Evidence-based approach means that everything what we discover, I have to prove, and I have to give evidence where it comes from which day, from which part, from whom. So that everything what we do is clear and is proven. A risk-based approach, I would change it to risk potential-based approach. That means we have to do an audit where we are evaluating the most potential and the most risk in a certain discussion. Guidelines. Okay, the ISO 19011 from 2018 is a good example. And so I would like to have some definitions, some wording. But also the BUT reference document for the manufacture of glass is a very, very good document of information you can use to optimize. If you're looking then into the ISO definitions of words, these are the words defined in the ISO norm. And you can see here you cannot find some words, but you find others. For example, program. In the language of audits, program in principle is a project. It's not, or for example, you will not find the word result. You find findings, conclusion. So in principle, it is just showing you there is this audit, this norm, ISO 19011 is a good example to structure your work. And this is so what I see, an audit is a structured process. If you are looking into, I like this word cloud. So these are the words when you are checking the ISO norm. You can see many words: program, audit, information, requirements, criteria. These are the words from the complete ISO. Okay, the BUT technology, the BUT reference document is about 500 pages. Really, it's a good source of information. Unfortunately, the new publishing I think is expected in this year or so, but it's not there yet. If I then add all these words, then you can see here that we are talking about NOx, energy consumption, gas, technique, efficiency, milligrams, CO2, BUT. So you can see these are the words. I just want to make it more interesting that it's not just one picture after the other. Motivation of an audit. For us, it is to localize the problem or to identify some potential for saving, increasing, reduction. The motivation is also that the customer would like to have some proposals for overcoming this dilemmas, problems, potentials. It's also to reviewing and verifying information, and of course, that opinion. But there are much more different options, but why people are choosing an audit. For example, to check the efficiency of internal controls, evaluating risk management. These are typically what also I've seen many times. So the third opinion, I think, so this is something what is quite important, and this is, I want to have a nice joke on it, but you can see here on the screen. Third opinion is in many audits I do or we do, so the customer who knows the most of the production, but the person who knows that, he is not, he has no audience in his own company. They do not know that he has this idea, or politically, internally, they do not accept that solution, what he has. So third opinion is that, that we as an independent company, we are coming to maybe the same internally already known, but then it is an audit, this is external. So this is then public, internal public. So this helps a lot. Third opinion is a very important issue. The phases of an audit is also quite clear. Planning, so in principle, we have to define the problem. We have to be really clear. So what we're talking about, is it a codan, is it furnace, is it a mixture, is it a batch house? We have really to define where it is. We have to define the program, the project. Projects can be projects. We have to set the scope, the time frame, and so on. So in principle, we have really to define it clear that at the end, the customer is happy and is not thinking that we forgot something. Activity is also clear. Objectives, very nice. It is like typically what objectives are is increasing productivity, increasing production, increasing factor melts, reducing costs, increasing quality. So these are typical objectives, and also like potential, like that the problem is identified, the potential is evaluated, and where, and so on. In some cases, also increasing revenues, but this is something, it's not technical mostly, this is more sales. So it's not our focus. We are more on the potential risk side and also on the production side. Now coming to resources. So resources can be everything. It can be gas, it can be raw materials. And the question is always to avoid, to substitute, to reduce, and to recovery. It's not like 3R, what is on the picture. It's not 5R, it's not 7 R's of sustainability. No, it is just these 4 points. You have to look into it. Okay, I can skip that. Resources are not so important. So because I spoke about already. So in the end, you have to find something that it exactly matches what a customer wants. And then it's clearly defined, and when it's clearly defined, then it can work. Okay, sometimes, and then I come to the execution of, in principle, in the language of audit, is conducting, is not executing. So some part of it is on-site, we speak with the people, we do an inspection of the location of what is to inspect or to audit, we collect the information, we do some assessment at home, we analyze, we calculate, we compare, we review, whatever is needed in audit. As being said, the audits are always different. So, but comparing is something, so what is always needed. So comparing is when there are situations of production what are very good in some of them, and some half year later they're bad. And there's always a question why it was good half year ago and a year later it was bad. So this is compare, we are comparing measures, we are comparing campaigns. And when we are comparing the campaigns, then we try to make things comparable what are not comparable. For example, how you can compare 200-ton production with 250, or green glass with white. So that means in German or in Europe speaking, you would say apples with pears, and the English speaking, you would say apple with orange. So it's just comparing is an easy thing. And what we are comparing is, we would like to know the cost, for example. Then we need to know that we cannot compare float with container, same quality, please. So then we have to see, is it different campaigns? Is it different furnaces? Is it different concepts? Is it against average of the industry? So then we do a normalization. That means we try to make just things comparable. I will not speak about in detail. That is too much time. But okay, some campaigns, and you can see on the screen, there are many different campaigns. You have to know, and you have to be a glass person. Otherwise, you do not know. You cannot just do an audit and then say, if you do not understand the process. And I'm in this also my colleagues, more than 30 years. And this helps a lot because I've seen many things. For example, here, this is production versus energy consumption over a long period. And you see here, there are some parts that are quite good and some parts are not so good. The question is, under what circumstances it was good and under what circumstances it was bad. So in principle, this could be done by just an analysis. Now, the next step is to identify why and what happened and how to overcome and find the potential. Here, this is, for example, now a comparison within a group. It is then, for example, here, this is against the benchmark. That means here you can see when you are good or bad. Here, this is when we are comparing different concepts. We have, this is published in another document, when we are comparing different concepts, starting from regenerative, recuperative, hybrid, all oxy-fuel melter, whatever. So in principle, this can be always part of an audit when the part audit is, for example, in an investigative one. For example, so a customer wants to know about future in combustion due to CO2. Then it's about concepts. There are many different ideas. CO2 emissions, I come to this a little bit later. It's not so important now. Total cost of concepts. So I can speak about this slide half hour because it's very detailed, but I just want to show that this is a part of an audit. It's analyzing and afterwards showing proposals and suggestions and helping and not just analyzing. CO2, for example, it is now it is a trend. CO2 reduction until 2030 is at least 55%, not 40, it's 55%. So, and the EU target for 2050 is climate neutral and not 80% what we always think. So I think this is the glass industry has to do something. So we are getting audits to investigative one that they ask us, so what can we do? So how to, is it electricity? Is it hydrogen? So where is the hydrogen coming from? So, and you see on the conferences right now, everywhere, there is hydrogen CO2. And they ask us, it's not just the conferences, they ask us really what they can do and do it real work. If we are comparing things, scenarios, so okay, this I can switch, this is not so important. Details, for example, when we are doing a furnace audit, if furnace is many details, can be burners, it can be other machines, it can be a battery charger, it can be electrodes. But for example, as an example for burner, so we are checking many things. First of all, we are visiting, we speak with people, we are doing a visual inspection, we check drawing specifications. And now it's a very important part is it clear so that the parameters, I will speak in a moment, are documented. So I've seen many times that there is an expert going somewhere and optimizing the combustion, and afterwards the customer is happy, and after half a year the production is again more expensive, more emissions, and then we ask them, so can you do not go back to the time when the expert was there? Then we find out nobody has documented that. Parameters like angle of the burner, fuel distribution, inner outer gas, and so on. In principle, in many cases, we find out that that this is not documented. So then I say in our report, we will tell the customer, please implement such protocols, and please the protocols can be also checked by database and not just a nice list, but a database conform protocol. This is not difficult, it's just a table. Also important is maintenance. So for example, is an old burner in place or a new one? How often is cleaned? So is there any inspection done already? And when, then I want to know, then I want to see the document. Also audits, is there any other audit already done? Yes or no? Is a modeling study already done? Yes or no? So and so I would like to know everything, but what is around burner? But it's not just a burner. It can be, it is a huge information. In the end, we have thousands of documents to check. For control, we want to know, or we want to check, is every burner individual controlled? Is there a model, is there MPC connection, for example, like expert system or others comparable, no doubts? Or is there some adjustment and motor adjustment of the burners? We would like to see if it's there or not, and then we can suggest to the customer, we would like to do that. We like to do that. It is also like, is emission control available, yes or no? Then we suggest them to invest into that to get more control. There are many, many things. So in the end, it's about to find where it was good and why it was good, and found out when was bad and why it was bad. Oxygen at furnace exit is a typical part also in, so when talking about combustion, it is, there's so many things why there is so many faults here and why there is excess oxygen. In principle, we are checking every of these options, and in the end we come to the conclusion it is the peephole or whatever. It's we are checking everything in detail, and this is a lot to check. The tools we are using, it is quite simple. We use every expertise we have. And I am not an expert of float, for example. I'm not an expert of inspection for container lines, but I have some expertise and others have other expertise. And we are using the team how it is needed and which our skills. Office statistics software, no doubts. Some own specific software, also clear. Statistical software, there is many on the market. I'm quite a friend of Excel and R, simply because everybody is using Excel, and if Excel is not going to make it, then I use R, because R is for free and it's very good. In the future, it is not Excel, maybe it is Google Sheets, not Sheets, sorry. And but I like the Excel because the Excel database can also use the information. In the future, I see some other software in place. To be honest, I checked a few, but I have not used this commercially right now. But in the future, I see this more. So when we do own applications on basis of Excel, then there are many things. We are not just giving just a report. We are giving really detailed information and systems where the customer can play. He can play temperature. He can play pricing. So this is, so we always supply those things. Okay, we have a database. I do not need to explain. This is, and also, of course, the database has also a connection to our expert system. This is clear. We can do some nice diagrams. And now coming to the last 3 slides. When we find something, we draw some conclusions. Then we will point out that we suggest the customer to check something, to measure something, to modify something, to implement database protocols, to better do procedures, and so on. We always try to suggest something when we do an audit. Product, if this was service, now we would like, then in the end, we also tell that we would like to invest into thermocouple. We maybe say that we suggest the customer to implement, to change. So in all these type, from processing, air preheating, waste gas treatment, we have ideas due to our expertise. Our expertise, we give some proposals what to do. Report is clear, as being said. It is not just a report. We have an executive summary for management. We have all the figures of the presentation. We give the lists, we give the databases, we give the Excel sheets that the customer can play, and in the end, it's a nice document. Okay, for example, here, then you see, for example, if you are looking on the furnace, there are some tasks we typically do, and the outcome in the end is for furnace we have to do these 68 things, and then in the report this is reflected. Some references. This is really my last slide. So in principle, we do everything what is about due diligence, technical due diligence, plant audit, hot end audit, furnace audit, conformance audit. This is what we really have done. Everything what is blue is what we have really done. And it can be furnace audit, but no one furnace audit is similar to the other. In glass segments, in almost every segment, except Fritz industry, in every of these segments, we have done an audits and we find the right people to audit. In countries, I was a little bit careful, otherwise you can see from which company, so I'm not saying that, but in many countries, and we are doing 2 to 3 programs, projects a year. This is what we typically do. So I would like to thank for attention. I hope you have enjoyed my presentation, and I'm open for questions. Thank you very much.
Thank you, Hans. Perfect timing there on your 30 minutes. Well done. Thank you for a very interesting paper there. And we're now open for questions through the question and answer icon. If anybody wanted to talk, then please raise your hand. But while we're waiting for some questions to come through, Hans, could you tell me what would be the likely time it would take for an audit?
This is a very good question, because when a customer is interested in an audit, he has a problem, he is losing money. So he wants to have it done as fast as possible. But unfortunately, it's not done in a day or in a week. So I would say we are talking here about 3 weeks at least. Yeah? 2 to 3 weeks, because we are on site a week. Depends on the scope, but it is not so fast as the customer wishes.
And yeah, after the initial audit, do you go back in 3 months, a quarter, 12 months? What's the timeline?
So what we are doing is we give suggestions. So, but what we do not do is every half year. So this is for that it is, I would say, it's every time, but so once a year, every 2 years, every 5 years. It depends. It depends how deep was the audit.
Is the challenge a cultural or a technology change when you make suggestions after your audit?
I think it can be a mixture. So it is sometimes it's a cultural issue, but in typical case it's that people are not doing what they could do. Maybe they have no time. It's not always that they do not see that, but we have a chance to do 4 weeks and deep analysis of a problem. In the customer, there is maybe an engineer, he has no time for 4 weeks to identify something. He has production every day, he has people every day. So I think we spend time somewhere, and this helps a lot.
Is that one auditor or a team of auditors that do the 4 week?
It is always a teamwork. The question is who's on site. So we can be 2 on site, we can be 1, we can be 4. It depends on if it's, for example, I would be, I am not an expert on ice machine forming. Then I would use another person who is an expert in ice machine forming. And then we come in with 2. Sometimes it's maybe, so, but we are not with 5 or 10. No, I would say 2 to 4.
Well, we had one question from Nilesh, who, just reading his question, I think you partly answered his question based on people, but I'm reading it as I'm speaking. So, what tools do you use to make measurements other than O2 analysis? Endoscope, pressure measurement, and parameter?
So you mean if we do some emission measurement? Of course, we have the device is not the cheapest one, but it's not just a small device, but we can measure continuous. We have a system from Madura, for example, so we can use this to identify easy potential. So we do some measurement, but for temperature, for example, we are not installing some thermocouples. This is not what we do. We check if the thermocouple is in order, is working, not working, is the temperature okay, is it direct, indirect? So we are checking those things.
Okay, thank you. So I was conscious of time, and we can have an open forum at the end of the afternoon for all the panelists to be involved for questions from delegates. So thank you, Hans, for your time, for your effort, and a very interesting paper.
Thank you very much. My pleasure.
Okay. So moving on to our next presentation. This is from Rob Ireson from Glass Futures. Rob is the Innovation and Partnership Manager of Glass Futures, with responsibility for the oversight and development of all Glass Futures R&D activities. He works closely with stakeholders, trade organisations, government funding agencies to ensure the innovation strategy for Glass Futures is aligned with industry and government roadmaps. Previously, Rob spent 8 years working for GTS, where he was responsible for managing long-term development research projects within GTS, undertaking a wide range of R&D activities in glass science and technology, including the development of low-carbon fuel technologies, new raw materials for glass making, and glasses for biomaterials, lasers, and 3D printing. During his career, Rob has filed 5 patents and written 28 successful funding applications, securing more than £31 million worth of grant funding. So over to you, Rob. Thank you.
Thank you very much, Nigel. Can everyone hear me okay? Just checking. Hope you can hear me.
Just raise your volume, Andrew. Rob, you're very quiet.
Am I very quiet? How's that? Is that any better?
That sounds a lot better.
Okay, that's great. Yeah, thank you very much, Nigel, for the introduction. And thank you very much for inviting me to present this afternoon. It's a real privilege to be here. Now, we all want to do our bit to help the environment, don't we? In our house, we like to recycle glass bottles and tin cans. We're trying to eat less meat and try and drive less. However, it's one thing reducing our own personal carbon footprint, but where do we start when it comes to improving the sustainability of something as big as the global glass industry? And it's clear, isn't it, that our industry faces a massive challenge. For example, last year, it's estimated that our industry, the global glass industry, generated more than 130 million tons of carbon dioxide. So that's the equivalent to the CO2 emissions of more than 27 million people. And it's also clear that if our industry doesn't make itself more sustainable, there's a very real risk that our customers will stop using glass and will move to other materials. Now, certainly the message we've had from a number of the major brand owners we've been talking to recently. Therefore, as an industry, we have to act, and it's clear that doing nothing is not an option. Now, over the years, our industry has done a great job at making progress. For example, it's estimated that the glass furnaces today use less than 50% of the energy to melt glass than they did 40 years ago. And this has been through developments such as more efficient and larger furnaces, the use of better refractories, and the increase in the amount of recycled glass used. However, the problem is that we're now reaching the limit in terms of how much more efficient we can make a natural gas-fired furnace, and therefore a step change is needed if we're to find a way to make glass manufacturing truly sustainable. But how do we go about doing this, especially given the costs and the risks involved in taking a technology from the lab scale all the way up to a commercial furnace, which can be up to as much as 4 to 5 orders of magnitude bigger? Well, this is exactly why Glass Futures was created. Glass Futures, we're trying to create a global centre of excellence that we hope will act as a platform for groups from across the glass sector to come together to develop these technologies that are needed to deliver zero carbon glass furnaces. And we want this platform to be open access so that anyone can work with us wherever you are in the world, and whichever bit of the glass sector or the supply chain you work in. We want you to be able to come to Glass Futures, and together we want to catalyse that research that is required to change our industry. Now, I'm sure everyone here will be very familiar with the fire triangle. I certainly discovered the importance of the fire triangle when I recently tried to have a barbecue recently, and it certainly didn't help that it was raining at the time. But it's clear that, and we all know that to get good, well-controlled combustion and to have nicely well-cooked sausages, we have to bring together the right amount of fuel, with the right level of oxygen and heat. Too little or too much of any of these factors can lead to serious problems, especially in a glass furnace. I would argue that it's the same with research. If you don't have the right people working together in a well-managed collaboration with appropriate funding and the necessary test facilities, then you're unlikely to deliver a successful outcome. So my problem with our barbecue was that I had plenty of fuel, but not enough heat or oxygen. So the burgers took forever to cook. But I think it's the same with research projects. Often people try to do research without approaching it in the right way. Either they don't have the right management tools in place, or they don't have the right people with the right skills or the right tools or equipment. And even if they do, then if you don't quite get the balance of those things right, then it's unlikely that results will be delivered in a meaningful way in the right time frame or on budget. So at Glass Futures, we're working really hard to bring these ingredients of collaboration, funding and test facilities together in the best way to deliver the results that are needed to make our industry sustainable. So first of all, we're really working hard to drive collaboration across our industry. We're working hard to identify and to bring the right people together, people with the right expertise, people with the right ideas, and with a passion and desire to make a difference. So both through the Glass Futures team of experts and our wider networks, we feel that we're really well positioned to do this here. And our aim is not only to identify who can support the research, but we want to identify the best people to work with across industry, but also across academia and the supply chain and across other sectors as well, to try and bring everyone together so we can all share our knowledge and expertise and really work together to deliver results. However, it's not just good enough to have the best people working on the team. As any football fan will know, you can have the best players in the world, but they're not necessarily going to win. So therefore, it's very important that as we bring people together, we actually provide the context in which they can work together most effectively. So as well as developing the networks at Glass Futures, we're also developing the collaboration tools that are required to ensure projects are well planned and well managed, to ensure that we've got clear objectives, and we've got tools like IP management and exploitation strategies in place, so that we can deliver results that can not just deliver technical results, but that can actually be successfully commercially as well. But it's not enough just to have the right people and the right tools for them to work together. And fortunately, they also need money. With the best will in the world, there's only so much that people can do without any money. This is why Glass Futures is putting a huge amount of energy into applying for funding to enable our research, both grant funded and private funding. We've been very successful so far. We've managed to secure over £40 million over the last few years for Glass Futures and our partners. And on the screen, you can see some of the some examples of the current funding streams that are available and which we're currently pursuing. So please do get in touch if you're interested in any of these, or even if you're just interested to find out what funding out there might be for you. I'd be very happy to try and help you in that. So you might have the right team and the right people, but thirdly, you need the right tools to do the job, which is why at Glass Futures, we're looking to develop a whole range of test facilities for the glass sector. We realise that the biggest need for the glass sector right now, we think, is the need to have an industrially relevant platform to trial and develop new technologies, which is why we're really putting a huge amount of effort into developing a 30-ton per day pilot facility, which will be based in St Helens. You might have seen in the media recently that we actually got planning permission granted for this building. So that means we're very much on track to deliver a fully commissioned and fully operational facility by the middle of 2023. And we want this facility to be a truly flexible platform that can trial any new technology that the glass industry might want to develop, be it in the furnace, such as new control systems or exploring new low carbon fuels, through to the forming end and the cold end, so developing new inspection technologies or new coating technologies. Our aim is to provide a platform so technologies can be developed and then de-risked, so that when they are transferred onto a commercial line, that can be done as smoothly as possible. And then another asset we're developing at the moment is our multi-fuel combustion test bed. So we're developing that within the fuel switching project, which I'll talk a little bit more about in a moment. The aim of this combustion test bed is really to provide a platform to benchmark a whole range of low carbon fuel options and scenarios against natural gas. So as you can see from the image there, there's a whole range of different instrumentation on there. We can preheat the gases coming into that chamber up to at least 1,000 degrees. So the idea is we really can simulate the conditions we might expect to see inside a real glass furnace. And then as we go forward, we actually want this to be a really flexible tool that can actually explore a whole range of different furnace scenarios. So at the moment, the combustion chamber, you can see at the bottom of the screen there, that's to simulate an end-fired container furnace. We want in the future to develop other chambers that can simulate, for example, a cross-fired furnace, and then hopefully even we can design a rig that can melt glass in there as well, so we can begin to understand how different fuels might affect the glass melting process itself. So I hope now that you have a good feel for all that Glass Futures and our members are doing and how we're working to create these collaborations and to secure funding, and how we're developing the tools required to help our industry to become truly sustainable. So I'd now like to spend the rest of this presentation just showing some examples of how Glass Futures and our members are bringing these ingredients together to deliver real research into low carbon technologies. So my first focus is technologies looking at the furnace. So as well as the development of a bespoke furnace for our pilot facility that can assess a whole range of low carbon fuels and other technologies, we're also working with our partners on a range of other projects in this area, such as the development of new waste heat recovery technologies, as well as new combustion systems that offer the potential to reduce NOx and to improve furnace efficiency. However, the largest project we're working on at the moment in this area is our fuel switching project. So this is a £7 million project funded by the UK government. It's got over 20 project partners. It started in January last year and runs until the end of March next year. And we're really, in this project, we are aiming to have a really comprehensive approach to understand the what low carbon fuels are out there and how they might be implemented. So as well as looking at the technical challenges involved in switching to low carbon fuels, challenges such as what happens to how the glass melts and what happens to the combustion characteristics. So as well as looking at the technical challenges, we're also looking to build an understanding of things like the environmental impacts of combusting and of burning alternative fuels. For example, what does it do in terms of emissions? And what does it do in terms of health and safety on the site as well? And then fourthly, we're looking at the economic considerations of switching to these fuels as well. Now we've already had done quite a lot of work in the project already and got some really interesting results. So in terms of the smaller scale trials that we've done a series of trials with Celsius, looking at how glass might melt under a hydrogen combustion atmosphere. And we've had some really interesting results here. We've both identified some of the challenges that might be associated with using hydrogen. So we've seen that we get, for example, more foaming when we melt certain glass compositions in a hydrogen atmosphere. But we've also seen some really sort of potential positive impacts as well. So for example, it does look like if we're melting glass under hydrogen, then it might impact the viscosity, potentially reducing the viscosity in the melting point as well. So still an awful lot to do to truly understand how hydrogen might impact glass melting, but we've certainly had some really interesting initial insights which will help to shape future work. A second area of work that we've recently completed is a series of combustion studies with DNVGL in the Netherlands, who have been looking at comparing oxy-hydrogen combustion against natural gas. And again, these results have been really encouraging. So we've seen that it is possible with hydrogen to get a really nice stable flame with a decent shape and decent flame length. And also, very interestingly, we've seen that it's possible to get a visible hydrogen flame as well, with good emissivity and good heat transfer. And we'll continue to build on this work later in the year when we start our trials on the combustion testbed, which I showed you previously. And in that project, we will be looking at hydrogen combustion with air, but also various blends of different fuels as well. In addition to our smaller scale tests, we've also done some larger scale trials as well. So earlier this year, we had a really successful trial at the NSERC Derrylin site, where it was possible to run one of their furnaces on 100% biofuel for 3 weeks continuously without any major problems. You can see in the slide there, one of the bottles that was made on that trial. Oops, sorry. Yes, this was a bottle that was manufactured for Diageo. And as a result of these trials, we are planning to have a follow-up trial on a float line later on this year, where again, we hope to run the line for a number of weeks on a biofuel. And we're looking to complement this work with a range of computer simulations and models, again, looking at different fuel scenarios and the implications of those, and whether we might need to modify the furnace at all to enable these different fuels. And to complement that, we're also looking to undertake an actual engineering study to look at how we might switch a standard glass plant operating off natural gas and how we might switch that fully over to hydrogen. So that's not just looking at the furnace, but also looking at aspects of the line, such as the four hearths as well. And then finally, within our fuel switching project, we're developing a really detailed economic modeling tool. So the aim of this tool is to help manufacturers answer questions like, when would be the best time to switch to low carbon fuels, and which fuels should I switch to? So we're designing this tool with the capability to map out how both the CapEx and the OpEx costs might vary over the next 50 years, and also to look at other aspects such as the impact of these fuels on site CO2 emissions. And our aim is to provide glass manufacturers with a tool that allows them to input the specifications for their plant and then to explore how various different fuel switching scenarios over the next 50 years might look like for their sites, so they can really build that understanding of what fuel switching might look like for them. So that's the fuel switching project, but we realise that if we are going to fully decarbonise the glass manufacturing process, we need to look beyond just low carbon fuels. So therefore, alongside our fuel switching project, we're also working on a number of other projects that will hopefully help move the industry towards that goal of sustainable glass manufacturing. So one area we're looking at is looking at developing new raw material technologies. So an example of that is shown on the screen. So this is a project we're working on that's being led by Glass Technology Services called EnviroAsh, which is mapping out a whole range of different waste streams across other industries to identify if there's any that can basically be taken and then processed into raw materials that might be suitable for the glass industry. And then we're also looking at the development of new digital tools and technologies as well. This is something that's come up in a few presentations over the last few days. And within Glass Futures, we've got a few projects and areas of work where we're looking into things like how we might help a glass manufacturing site connect up all of the different parts of its manufacturing process into one platform, so that then the manufacturing data can be analysed. We're working with a group in the UK that owns some of the UK's fastest supercomputers to try and take all that data from a glass manufacturing site and see if we can spot trends and patterns and ways of really optimising the glass manufacturing process. And then we're also exploring how we might develop tools such as digital twins that might just really provide interesting insights into how we might automate the glass manufacturing process in the future. And then alongside all of this, we're very keen not just to work within the glass sector, but to work with other sectors as well. So we're having conversations with people in the steel industry, with people in the ceramics and cement industries as well, to see where we can actually kind of pool resources, where we can work jointly on different technologies so that we can develop them more quickly and more efficiently to deliver better results. So I hope this afternoon I've given you a good feel for what Glass Futures is and all the different work that Glass Futures and our members are doing to try and help the glass industry. I'd like to stress that there are loads of opportunities if you want to get involved in glass futures. So you'd be very welcome to get involved in our design process of the pilot facility in St Helens. There's opportunities to engage with our fuel switching project, as well as to partner in funding bids. So if any of that is of interest to you, please do get in touch. We'd love to chat to you about how we can support your research. And as we come to the end of the presentation, I just want the message I want you to take home this afternoon is that Glass Futures is here to help you. We want to help you make a difference to your industry. We're keen to ignite those R&D activities that our industry needs to do in order to make glass a truly sustainable material. And I'm confident that if we do work together, we can create the right collaborations and the right tools that will help us achieve this goal. So thank you very much for listening. It's been a real pleasure to be able to talk to you this afternoon. And please do let me know if you have any questions.
Thank you, Rob. Really interesting presentation there, and it must be quite very exciting working at Glass Futures, seeing the future of the glass industry being developed. Well, we wait for some questions to come through. Just one for me. Could you say which low carbon fuel do you think has the greatest potential for decarbonising the glass furnaces?
I think at the moment, can you still hear me okay? So I think the answer to that is we just don't know yet, is one answer. But then I think the other answer is, I think there could be a number of different answers to that question. So first of all, it's going to vary very much in terms of how the future pans out. So we know that there's a whole range of different types of research going off in other sectors, looking at how, for example, how to generate hydrogen in an affordable way, but also looking at developing new biofuel options. And I think over time, the economics of that and the availability of these fuels will change. So I think as a glass industry, we have to kind of effectively back all of the different fuel options. We can't just kind of put all our eggs in one basket. And that's why within our fuel switching project, we did keep all those different options open, and we are looking at all those different fuel technologies. So I guess it's a bit of a kind of cop out of it, but I think the real answer is it could be any of them.
Mm-hmm. I guess it's dependent on geography and the fuel sources being economically generated in the different regional areas of the world.
Yeah, and it will change over time as well. So it might be that in the next 10 years, there might be one solution, but sort of from 2040 onwards, it might be a different one as well. So you've got to try and factor that in.
Okay, and Glass Futures, how is it protecting the glass and UK glass industry, or how are you protecting the chances of duplication of the research that you are doing and with the other organisations in Europe that are looking at alternative low carbon fuels?
Yeah, so I think within Glass Futures, we want to set ourselves out as a global centre of excellence, not just kind of UK or even Europe. So what we're trying to do is really reach out to all of the different groups out there doing research in the areas that need to be looked into to make our industry sustainable. So we are in contact with groups like Celsius, as you saw from the slides. We're also talking to people like IPGR, BV Glass, and we're keen to reach out to more of these groups as well. So what we want to do is not duplicate the work that's been done, but we want to understand what work's been done out there and then work out where the gaps are and how we can complement that. So for example, how can we sort of take some of the lab scale work that's been done out there and then use the pilot facility in St Helens to try and get that technology up to an industrially relevant scale. So I think I would say actually, if there's anyone sort of around the conference today who's working in any of these areas, please do let us know, because we are keen to just find out what is going on out there and how we can complement it.
Okay, great, thank you. I've got a question here from Elaine. Are you also looking at the feed streams of hydrogen, since other industries already have a high usage of? If the glass industry looks to switch completely, do you anticipate assisting other producers of hydrogen to upscale their production as well?
Yes, I mean, at the moment, our remit is really to understand if hydrogen is suitable for the glass industry. So all our work is actually just looking at sort of the combustion of the hydrogen, not necessarily looking at where it's come from.
Okay.
However, that said, we are working really closely with a lot of the other groups that are developing those hydrogen networks, and we're in conversation with the government as well. So within the UK, there's the Department for Business, Environment and Industrial Strategy. So we're having regular dialogue with them to understand sort of, and also to help shape their strategy for kind of future fuel scenarios. So I think we're still very keen to understand sort of where the hydrogen might come from. For example, in the economic model I mentioned, we're trying to make sure that we've kind of got accurate forecasts in that for things like pricing and sustainability and CO2 associated with the manufacture of the hydrogen. So I think I would say it's something of interest, but it's not something we're directly partnering with just yet.
Well, I've got a number of questions coming through, so sorry for cutting across you there. Question from Alan Stevens at Fewstein. He asks, you showed that there are problems melting amber glass. Are you looking at viable alternatives to reduce glasses?
So I mean, I just showed one slide. There was quite an extensive study done there, but again, it was a preliminary study. So it is something we realise we need to understand, particularly for all the different fuels. I think that it will impact the melting conditions. Mm-hmm. So yeah, we agree it's something we will need to look at. Okay.
I want to hear from Jan Turan at Lucidian. Are you focusing only on different fuels for different? Oh, sorry, the screen's just moved around. The screen's moving around. I've lost the question now. The question's disappeared. So apologies for that. Where have you gone, Jan? Oh, here we go. I'll start again. Are you focusing only on different fuels for current furnace designs, or are you looking at completely new furnace designs to suit specific fuels?
That's a good question. I think at the moment, the fuel switching project is looking more at the kind of how we might switch current furnace designs. But certainly one of the things we want to do in the future at St. Helens is to provide a platform to trial new furnace designs. So although our kind of iteration 1, which we'll probably implement to start with in 2023, might look like a more conventional furnace, we have designed that facility so that we can kind of quickly kind of take one furnace down and put a new furnace design in, and potentially even build a second pilot line at that plant as well. So certainly that desire to look at the desire to kind of revolutionize the design of the glass furnace, that is something that we would like to do in the future.
Okay, one last question. Rene, you had your hands up a few moments ago. Do you want to come in and ask the question direct to Rob?
Yeah, hi, Rob.
Hi, Rene.
As always, an interesting lecture. Yeah, okay, so we see a lot of differences in regions all over the world, and the availability and the cost price of fuels, of renewables and things like that. I think you already answered the question by the availability of your institute having the capability to test other types of furnaces in future, because I simply don't believe that there is one solution which fits. There's no one fits all. It will be a mix of different solutions. What is your opinion about that?
I think, as I said earlier, I think there's likely to be a range of different scenarios. Like you say, it will probably depend on geography and access to fuel sources. So I don't know if you have a particular region in mind or not, but I think even in somewhere like a single country such as the UK, I think it's going to vary depending on geography and when the different fuels come online. So we know that some areas of the UK, some areas of Europe will have access to industrially scalable hydrogen supplies sort of in the next 10 years even, whereas others, it might be sort of 2040 onwards. So I think in terms of, I suppose another way of looking at the question could be, are they going to work? Do we think they will work or not? And I think of all the different fuel scenarios we're looking at, the initial results certainly suggest that it is possible to melt glass with any of these fuel scenarios. I think there's also still a lot of work to do before we can fully answer that question, if we can truly melt them in a kind of reliable, continuous manner.
Okay.
If that answers your question.
Okay, then thank you, Rob. For another interesting paper. And now we'll move on to our next presenter, who was a last-minute reserve brought in today, Marcus Reinhardt from Glass Service. Saveway. Marcus is a new employee at Saveway, only joining the company at the beginning of this year as a field sales representative. He studied foundry technology in Leipzig and Freiburg, and has many years' experience of sales and development in the field of HPDC of aluminium alloys. And over the last few months, he's got himself very familiar with the technology, the terminology and technology of refractory monitoring. So I'll hand over to you now, Marcus, to give your paper.
Yes, I see you. And yeah, can you hear me?
Yep, can hear you fine. Nice,
Yeah.
nice and loud.
Yeah, thank you for your introduction, Nigel. Hello, everyone. I'm very glad to have the opportunity to introduce Saveway lining condition diagnosis in real-time technology to you.
Sorry for cutting across. Can you put your slideshow on?
Yes.
Great.
Okay.
Good to go.
Yeah. First of all, a few words about Saveway. We were founded in 1992 as a spin-off from the University of Ilmenau. The founder, Dr. Hoff, is still the sole owner and CEO. We have 67 employees, including our representatives in Japan, South Africa, and the USA. Most of our employees work in the center of Germany in Langewiesen. This is also where the equipment for our measurement technology is manufactured and where most of the engineering for all our customers takes place. These monitoring technologies are used in a wide range of metallurgical vessels. They are also used for monitoring glass tanks. These technologies use 6 sensor types depending on different application fields and monitoring purposes. With over 1,000 vessels monitored, Saveway is our main product. Electrode panels cover the entire surface of the melting furnace and detect even the smallest melting peaks in the lining. Over the years, other sensors and evaluation options have been developed and refined. What I will introduce you today is the Saveway technology applied to glass melting. Saveway is used in many parts of the glass melting furnace, such as the bubbler or booster, or on the floor, throat, and feeder. Generally speaking, in the process of glass melting, the defect of refractory materials is the penetration. Such defect will bring security risks. For this reason, it is very necessary to install sensors for some special locations to detect the remaining thickness of refractory materials in real time. For monitoring the remaining wall thickness of melting vessels, we use the physical quantity of the electrical resistance of the various lining materials. All materials shown here significantly reduce its electrical resistance with increasing heating. We can work with 2 measuring paths. One comb-shaped sensors form one pole each, and the measuring current passes through the layers of the refractory material. In the principle shown on the left, a net-shaped sensor, similar to a structural steel mat, forms one pole above the lowest brick layer, and the contacted molten glass forms the second pole. The sensor electrodes are embedded in fire clay. The current from one comb passes through the refractory material to the molten glass and then returns to the other comb next to it. In this way, we determine the electrical resistance of the local refractory material. Because we can know in advance the thermal conductivity of the lining and the resistivity at each temperature. We can calculate the temperature distribution in the lining, just like the different colors shown in the picture. The graph illustrates the significant decrease in the electrical resistance of the lining with increasing temperature. For visual clarity, the colder temperatures are underlaid with darker colors. Here in the graph, we use the different colors to illustrate temperature ranges to which we subsequently add values for electrical resistance. The change is 5 powers of 10. Because the higher the temperature of the lining above the electrode, the lower the resistance, and the current will always follow the path of least resistivity. The thinner the remaining lining, the higher the temperature of the refractory material above. So it means that the detected resistance is smaller, as the cases of via shown here demonstrate. According to this principle, we can monitor the remaining thickness of the furnace lining in real time. In addition to this sensor installation on the furnace, you will also receive a measuring unit in the center of the screen and the control unit with instructions. A second touch screen can be added. Let us take a look at the application. First, flow monitoring. As mentioned earlier, when monitoring the floor, the SafeWay sensor will be embedded in the fire clay to monitor the remaining thickness of the lining in different areas. The wire diameter of the electrode sensor is 2 millimeters. The groove height is about 5 millimeters. According to the above example, the area covered by 8 different colors in the picture is the monitoring distribution of 8 segments of electrode combs. In this way, the defect at a certain segment of the electrode can be located. The picture on the right shows the dedicated connections with the electrode protruding at the tank floor. The combs do not touch each other. In reality, the wires are laid 40 millimeters apart in height at the intersecting lines in the sketch. The system will continually record the remaining wall thickness of the furnace lining, which can be called up and viewed at any time. In this way, the history of the furnace lining during the melting process can be clearly displayed. From left to right, you can clearly see an increasing wear of the lining. In the picture you see now, the segment 3 detects that the glass has reached the sensor electrode. System alarms was displayed. During the lining teardown, the accuracy of the system will be calibrated according to the actual dimensions of each part. In the other segments, different conditions of penetrations were detected. In this way, a glass runout run through will be avoided. The following slides show installation examples, another floor monitoring. In the monitoring of the LCD glass tank, we used a mesh electrode to measure the resistance from the electrode to the melt. The electrode will be laid directly on the fire clay. In this way, the molten glass should be grounded. Such areas for bubblers can easily be cut out. This kind of mesh electrodes save installation time. The electrodes will be covered with a thin layer of mortar. The slide shows how we leading out the connections through the floor construction, crimped and protected by a fire hose. As mentioned before, the condition of each electrode segment will be monitored and recorded. Another application is the floor monitoring for glass fiber melting. On the left side, you can see the prefabricated sensor mat and transport packaging. Connecting wires can carry out easy to the position of the possible feed-through. This installation is quick and simple without grinding a special groove geometry. The net electrode installation will avoid of the bubbler area here too. We can see from this table that the remaining wall thickness gradually decreases with the time for over 7 years. Another case is throat monitoring. In this case, we use platinum as the electrode. The particular critical area is monitored with electrodes behind AZS plates. Sensors are installed underneath the pathing. In this example, there are 4 segments to detect the resistance of the furnace lining. They are placed on the left and right side and below. How is the area around the bubbler block monitored? This is an installation scheme. The rear of the bubbler block will be quantized displayed on the monitor. This slide shows you the 3-year historical record of one of our customers' bubbler blocks. On further slides, we see the application on the slug melter. The photo shows you sensor electrodes during relining. 24 segments are installed behind the side wall block. The sensor will be laid between the sidewall block and the backup lining. As we can see from the picture, the lifetime of the lining is about 1.5 years here. The wear of the furnace lining gradually expanded, and the wear of the spout and the feeder was the most serious. There is a further critical location at the glass tank, the doghouse. The entire doghouse is surrounded by a variety of electrodes divided into 8 segments. The electrodes monitor the entire lateral surface. How are they constructed? Stripe of insulation foils glued together fix two cup-shaped sensors. The sensor combs are made from nickel alloy wire, which is attached to a base by spot welding. The two combs interlock without touching each other and create one pole each. After connecting the wires of the sensors under the later floor area, further lining is applied. During operation, the wear for each of the monitored segments can be continuously visualized graphically. The position of the segments is shown in the diagram above the bar graphs. Warning messages on the display clearly show each operator when set trigger values are exceeded. Finally, let me summarize the advantages of this technology. Here you'll find an overview about the strengths of SafeWay. Easily traceable measurement data provide the operator with an up-to-date decision-making basis for evaluating the condition of the lining. Furthermore, with monitored lower lining thickness, for instance, improved new refractory materials, you can increase the efficiency and capacity of your furnace. Thank you for your attention. Do you have any questions?
Okay, thank you, Marcus, for another interesting paper, and certainly a new technology to me, and thank you for that. I've got one question, and please, more questions are requested. The first question I have is from Wolfgang Seelbach, who asks, is there a SafeWay installation at a multicolour furnace, blue, emerald, amber, flint, and how big is the influence of different colours and different pull rates?
I think these have no influence. What the measurement system do is monitor the refractory. There's no influence at the melt.
David Ferdinand asks, is there any influence on the refractory lifetime?
Or if you can prolong the lifetime of the refractory, or because you have a clear status each day, each minute, for what is the minimal remaining wall thickness. So far, you have a steadily base to decide how long do you can further use the refractory.
It's monitoring of life. Monitoring of life where? Refractory where?
The refractory well monitored in areas defined as critical areas or more in front of before installation, and so you check the wall thickness of these critical areas over the whole lifetime and during the hot status of the furnace.
Okay, good. I've got a hands up from Renee. If you go live again, Renee, and ask the question direct to Marcus.
Yeah, okay. Hi, Marcus. Interesting technology. It seems that you don't have any problems with electrical furnace boosting on your system. Is that correct? Because you could expect some influences coming from the boosting electrodes sitting at the bottom of a furnace. And then, of course, the question is, if that doesn't worry you, could you do something with the electrode block holders, where the electrodes holders are placed in, to sense wear on those electrode blocks?
If there is an influence, or if there is, it could be that there is an influence, but actually I have no concrete answer for that. I have to ask that, and if you can send me a mail, I can give you an answer for that. I'm not the expert in this for this application.
Yeah, okay. I kind of defend Marcus's position. He's new to the company and new to the glass industry, so he's
that's it.
Experience and if you can answer the question to me, Marcus, then I can give your answer to the delegates that are on the line now. Peter West from Ardar has asked a similar question about the influence of electric boosting electrodes. So we'll answer that question to Rene and the rest of the delegates in due course.
Yeah, I think this technology could be extremely important. If you put more electrical furnace boosting into furnaces, then of course we have a concern on wear in the electrode holder blocks. And if the technology would be capable to giving us some answers on that, that would be great. Huh? Okay, I'll stop here.
Yeah. Okay, good. Yeah, so
Stuart's got his hand up.
Is it? Okay. Stuart, please.
Yeah, very good presentation, Marcus, and certainly something I've never heard of before. Can you give us any idea of the sorts of voltages you're using through these wires?
Or it's 42 volts AC technology.
Okay.
Yeah.
Excellent. Thank you very much.
Then, of course, the question is, could you also use direct current? Okay, let's have a discussion.
Yeah, Peter West just asked the same question. Does the system use AC or DC?
Then you could filter, perhaps you could filter out. Okay, but okay, let's have this discussion later on.
Yeah. So moving. Thank you, Marcus. So if I could ask all the panelists to open their mics, or Christine to open the mics, and everybody is there now open for questions from the delegates. So, anything from anybody? No questions come through. The questions have just been cleared by our people. Yeah. Nothing? No, they're all very quiet.
Okay.
All right. No, just somebody just okay. Okay then. It's been a
Nigel. Peter West has his hand up. Hold on a sec.
Right. Sorry, Peter. Yeah, far away. You need to be unmuted. Hey there, Peter.
I was trying to think, have I unmuted? Can you hear me?
Yeah, we can.
Yeah, okay. I was thinking of a general question. We heard a lot about the future of new fuels and how glass will behave with new fuels. I don't know if I missed it, but a general point that maybe one of you can answer, and that is how will refractories meet the challenge of new melting technologies, boosting, and new alternative fuels? And what do we see the answers to these challenges?
Yeah, that's far from my knowledge too. I know it from the same issues in metallurgical vessels. It is a harder wear caused by hydrogen boosters and metal industry, a harder wear of the refractory material. But this is all still in our further further investigations have to done there, but that is not reflected up to us till now.
There was a recent lecture of AGC Ceramics on bringing the electrical resistivity of the refractories up. So having a bigger difference between the electrical resistivity of the glass and the refractory, which obviously is very important because you would like to have the current running through the glass and not through the refractory. I also found a Chinese company busy with a similar study. There are already some results. So okay, that's not specifically something from Celsius, of course, but it is of course a concern. If you put more electrical furnace boosting into a furnace, then it would, because of an advantage of the refractory material, would have a higher resistivity for electrical currents. Perhaps you could answer to that as well.
Yeah, it is.
Maybe as a refractory producer, maybe I can put our view in as well. Yeah, it's got interesting times, and yeah, certainly if the industry goes down the hydrogen route, then in theory, all the hydrogen is going to be combusted with oxygen to create water. So that's going to have an impact on the life of the refractory. But also, if the hydrogen isn't combusted, then there's an element of what the hydrogen will be energized enough to attack any silica that's there in the refractory. So yeah, if there's free silica, then it's a very easy target for hydrogen to attack to scavenge oxygen. But if the silica is bonded with alumina, you've got good mullite materials, then it's less attractive to the hydrogen. It's more difficult for it to scavenge oxygen. So it's from a refractory perspective, it's going to be an interesting few years for us to develop the relative materials, but it's a learning curve for the industry to understand what atmosphere they are creating or potentially creating, which could have an adverse effect on the refractory.
I think I would agree with that, Nigel. I don't know if you can still hear me. Yeah, and that's certainly one of our objectives in our initial studies, is to understand things like what kind of atmosphere do you get? Because I think that's the first question to answer, so that we can then advise what kind of atmosphere, what conditions the refractories will have to put up with. I think the second area where I see a slight gap is sort of if as new refractories are developed, how do we kind of test those as an industry and prove that they're safe and that they offer the durability? So that's something else that we as Glass Futures are trying to get the industry to look at, to work out how might we develop a facility that might allow us to do the tests that would give meaningful results on refractory performance.
Mm-hmm.
Thank you.
Okay, thank you, Peter. So, yeah, it's Jens Ron has made a comment that surely hydrogen would be burned, but how many of us would say that the burning system is 100% efficient, burning correctly all the time? Yeah, in theory, all the hydrogen will be burnt, but in practice, we know we get reducing atmospheres now. whether you want it by design or something that happens at 3 o'clock on a Sunday morning. But okay, so if there's no more questions, we'll move on to the final part of the conference, which is the Michael Garvey Award for the best paper presented for today's conference. Those that have been to the conference before will be well aware of the history of this unfortunate award, which was to commemorate the sad loss of Michael Garvey, who gave a paper in 2008 and sadly within hours of giving his paper had an unfortunate accident while climbing. And he was a well-respected young engineer at Guardian, and Guardian wanted to remember him so the industry could use him as a figure point, and created with us the Michael Garvey Award. So I'm happy to say that this year's winner of the Michael Garvey Award is Rob Ireson from Furnace Solutions. So thank you, Rob. Thank you and congratulations.
Thanks.
You look surprised.
Yeah, no, very honoured. Thank you very much for that award.
So
this is for you, Rob.
Okay, yeah, if you can see it.
Brilliant. I'll have to pop
yeah, it's a very nice, unique.
I have to pick it up from the offices.
That's right. Thank you very much.
Yeah, so it's you've got a unique piece of glass there. So there's since there's only 10, 15 pieces of that piece of glass in the world. So it's your heirloom for your children and grandchildren.
Fantastic. I have to display it in our new facility in St. Helens.
Yeah, great. Okay, so I'll wind up today's event. Again, thank you all the presenters. Yeah, it's been an interesting challenge doing it via Zoom, and I'm looking forward to having a beer with you all next year at the premiere at Trentham Gardens, and we'll laugh about this interesting event that we've had today. So stay safe. Stay happy, and thank you all for your time.
Thank you, Nigel.
Thanks, everyone.
Thank you, Nigel, for the organization.
Okay, thank you.